number 130, adding and subtracting rational expressions. Now, rational expressions is just another word for fractions. Well, what do we know about adding and subtracting fractions? You must have common denominators. So, by the way, there's a reason for that. Let's address this common denominator action thing for just a moment here. This is 1/4 here. We're going to color in 1/4 of a circle. We're going to try to add that to, okay, we're going to add that to this area here, which would be 3/8. So we're going to take 1/4 plus 3/8. Now, if we were to take two soccer balls plus 3 soccer balls, we'd get a total of 5 what? Soccer balls. Okay? So we can add these two numbers together to get one term. Okay? Now, if you took 2 soccer balls plus 3 footballs, we would just simply have a total of 5 balls, but we wouldn't know if they are, what kind they are, soccer or football. So, that's the reason for common denominators. These are pieces that are cut into fourths. This is 3 pieces cut into eighths. That's why we would need to make the 1/4 cut into eighths. So we just turn this area from 1/4 into 2/8. Notice how we used 2 more lines? That's why we multiply by 2/2 to get our 2/8 plus 3/8 to get our total of 5/8. 1, 2, 3, 4, 5/8. That's how it all works out. So, that's a little crash course in adding and subtracting fractions. Here's adding and subtracting rational expressions. We start off by noticing that the denominators are definitely not the same. To make the denominators the same, we go ahead and multiply the second fraction by 2a squared b over 2a squared b. Now, first question, why 2a squared b? Because we want both denominators to be an 18, a cubed, b squared. We need a 2 to make the 19 become 18. We need an a squared to make the a become a cubed. And we need another b to make this b squared. Now, we want the denominator to be 18a cubed b squared. So that's why we multiply by this 2a squared b to the denominator. Then, by law, we're not allowed to multiply the denominator and the numerator by anything different, because we need this problem to remain the same. It's kind of like this. If you did 4/3 plus 5, if you wanted to, we could change this to 4/3 times 5 times 3 over 3. What are you really multiplying by? You're multiplying by 1, which doesn't do anything. Multiplying by 1 does not change the problem. It just changes the way the problem looks. We're changing the way this problem here looks. So now it looks like this. Now it looks like this, but you have what? The same sized pieces. We changed the way the pieces look. They will look like fourths. We made them look like eighths. It's that easy. It's the same logic. Now, because the denominators are the same, you can subtract the numerators. 7 minus 4a squared b over 18a cubed b squared. You're done. Next one. M plus 5 over m minus 1 plus m minus 3 over m plus 1. Well, in adding two fractions together, so 3/5 maybe plus 9/4, one of the things that you could do is you could make the denominators both 20. Alright, now what we would do is we'd change this to a 20, change that to a 20, we'd multiply this by 4/4 and multiply this by 5/5. Again, Why are we multiplying this by 4? To make it 20. Why are we multiplying the top and bottom? Because you have to multiply each fraction by 1 so that it does not change the value of the question. Then you would just go from here. So then you get 12, you'd get 45, you'd add that up 30, you'd get 57 over 20, and you're all done. We're going to do the same exact thing. We're going to take this m minus 1, multiply it by m plus 1 over m plus 1. m plus 1 is missing m minus 1. m minus 1 over m minus 1. Now you have a common denominator of m squared minus 1 when you multiply these two out. Okay? Then we're going to multiply the numerators. M squared plus 6m plus 5. M squared minus 4m plus 3. Common denominators now. Like terms. 2m squared. 2m. 8. You're all set. Or, of course, you could have the answer in a factored form if you like. Either one of these is perfectly fine. You probably want to go to this step, though, more times than not, because there could have been a canceling, which would have made the answer in a reduced, simplest terms. All right, questions or concerns? Oh, wait, we got one more to do here. Here it is. So we got m plus 5 over 5m minus 8 minus m minus 3 over 8 minus 5m. Now in this problem, this is totally cool because it's very similar to what we looked at in one of the recent videos. I believe it's 128 or 129. Make sure you go back and check it out. But what you got here is this. We established earlier that 14 minus 3 equals the opposite of 3 minus 14. Think about it. That's 11. 11 equals the opposite of negative 11. It works perfectly. You can then change these numbers out and say, does it really matter what these two numbers are? What if it was 31? Wouldn't that still work? This is what? Negative 17 equals the opposite of 17. That's true. So it doesn't matter what the two numbers are. They could be anything. So there we are. We have this little discovery here. It's a discovery. We just discovered that a minus b equals the opposite of b minus a. Okay? We're going to use this fact to help us get common denominators. These are almost common denominators. So we're going to change the 8 minus 5m to the opposite of 5m minus 8. Isn't that a beautiful world? So we change the 8 minus m to the opposite of 5m minus 8. Now, this minus sign, along with that minus sign, become a plus. Then you add the like terms, 2m, because now you have what? Common denominator, same sized pieces. Add the numerators, 2m, add that 2, you're left with 2m plus 2 over 5m minus 8. Or, of course, what you probably would see this as is 2 times m plus 1 over 5m minus 8. Alright, so any questions or concerns, please send me an email, and of course, good times.